Think about the last time you had to learn a really complex physical skill.
Right, like maybe driving a manual transmission car
Yeah.
or, learning to surf.
Yeah, exactly. Or even just mastering a new power tool in your garage. Now, imagine trying to learn that exact skill entirely by reading a dusty 500-page paper manual.
That sounds like a nightmare.
It is, right. And to raise the stakes, imagine that if you make a single mistake, the equipment you're operating, which happens to cost several $1 million, could literally explode.
Wow. Yeah, that changes things.
It really does. And today's mission for this deep dive is unpacking how the industrial sector is desperately trying to solve a massive, dangerous brain drain that is, well, making that exact nightmare scenario a reality.
It's a huge issue right now.
We are pulling insights from an April 2026 announcement by EON AI Ventures. They just detailed their new Innovation Immersive Learning Center. But, before we get into the sci-fi level holograms and VR suites they are deploying, we really have to look at the ticking time bomb of the current workforce. Okay, let's unpack this.
Yeah, because the underlying catalyst for all of this technology is it's a monumental demographic cliff. The numbers from the industrial sector are just genuinely staggering.
I mean, looking at the source, I was shocked.
Right. Roughly 50% of experienced operators are nearing retirement in the next 5 to 7 years. We are talking about half the workforce.
Wait, 50%? That's not a transition gap. That is a cliff.
Exactly. Half of the institutional knowledge of the entire global industrial base is simply walking out the door to, go play golf or spend time with their families.
How do you even begin to capture decades of that nuanced, tactile knowledge before they leave? The financial impact of that expertise vacuum is just wild to me.
Oh, it's astronomical. Losing just one of these veteran operators costs the company anywhere between $500,000 and $2 million.
$2 million for one person.
Yeah, because of what happens when that knowledge leaves without being properly captured.
Yeah.
It creates this immediate, highly dangerous vacuum on the factory floor.
Which naturally leads to more mistakes, right?
Precisely. During these transition periods, operational error rates jump by 40 to 60%. And for the incoming generation, the kids who are supposed to replace those retirees, it takes them 2 to 3 times longer to reach basic competency.
It makes me think of an airline suddenly losing half of its veteran pilots. But instead of putting the new recruits into advanced flight simulators, the airline just hands them a chalkboard, a couple of textbooks from the 1990s, and says, good luck landing the 747.
Right, which is insane.
You would never accept that risk for a commercial airline. But in high-stakes industrial operations, leaning on a paper manual is practically the norm.
Which is wild, and what's fascinating here is it highlights the core failure of traditional classroom training in these high-stakes environments. The cognitive gap between reading a procedure on a page and, physically executing that procedure on dangerous machinery is vast.
Because reading a bulleted list about a high-pressure steam valve doesn't actually prepare you for the physical reality of it.
Exactly. The noise, the tactile feedback of a live industrial environment, you don't get that from a book. That gap between cognitive understanding and physical action is precisely where life-threatening errors occur.
It's like trying to learn how to ride a bicycle by reading a physics textbook about gyroscopic balance.
Right. Your brain knows the math, but your body has no idea what to do.
Exactly. The cognitive knowledge doesn't translate to your central nervous system until you actually feel the pedal push back. And the stakes here are so incredibly high. We aren't talking about a typo in an email.
No, not at all.
A serious safety incident in a chemical plant costs anywhere from $2 million to over $10 million per occurrence, not to mention the human cost. And then if you fail a compliance audit because you can't prove your people are trained, regulatory penalties easily exceed $1 million.
So to remain competitive, organizations have to solve for safety incidents, knowledge transfer, and regulatory pressures all at the exact same time.
Yeah.
The traditional classroom, or, shadowing a veteran worker, those methods just aren't built for the operational tempo required today.
Which brings us to the solution EON AI Ventures has put forward. They are looking at this dangerous gap and essentially saying, we have to digitize the veteran operator.
That's a great way to put it.
Their announcement unveils the Innovation Immersive Learning Center, which is a turnkey hardware suite blending immersive display technology with AI-powered competency verification. Here's where it gets really interesting, though.
Oh, absolutely.
I have to push back a little bit on their approach. Why on earth does a company need an entire suite of 6 different physical display systems. If the goal is immersive training, why not just buy a giant crate of VR headsets, hand one to every new trainee, and call it a day?
Well, that is the assumption most people make.
Right, because it sounds cheaper and easier.
It does, but if we connect this to the deeper psychology of how human beings actually learn, throwing someone straight into VR is a terrible idea.
Wait, really, why is that?
Because learning has to be a deliberate progression. You cannot take a brand new hire who has never set foot on a factory floor, isolate them in a fully immersive VR headset on day one, and expect them to absorb complex, dangerous procedures.
Because it's just too much at once.
Exactly. The cognitive load is simply too high. Their brain goes into sensory overload, and they end up fighting the technology instead of learning the procedure.
So if you isolate them immediately, they have no spatial context. They don't understand how the machine fits into the larger facility.
Precisely. Effective training must flow along a cognitive ladder. It has to start with group conceptual understanding, where everyone is looking at the same environment and building a shared mental model in a psychologically safe space.
That makes a lot of sense.
And from there, it transitions down to collaborative troubleshooting, where small teams interact with specific components. Only after that foundation is completely solid do you move to high-stakes, isolated solo simulation in VR.
So the EON suite is specifically engineered to facilitate that exact psychological progression. Let's actually trace the journey of a new trainee climbing that cognitive ladder because it paints a fascinating picture.
Yeah, let's do it.
It starts with establishing that macro-level context. You mentioned building a shared mental model, which EON accomplishes first with what they call the concave.
Right, the concave system.
This is a massive, curved, life-size 2D and 3D display that can physically fit up to 30 people inside it. And it features 5.1 spatial audio.
Which is incredible for group training.
Yeah, so a whole class of trainees can do a highly realistic facility walkdown before anyone ever steps foot on a dangerous little active site.
The psychological benefit of that group setting is profound. You are orienting a team to a hazardous environment with zero physical danger.
Right, they're safe.
They are learning where the emergency exits are, mapping the locations of high-voltage areas, and understanding the sheer scale of the facility together as a unit.
So they can point things out and ask questions in real time.
Exactly, and build collective situational awareness. Alongside that, they utilize the EON Eye Catcher, which is a high-definition group visualization screen designed for breaking down those massive environments into, manageable classroom-level modules.
But understanding the high-level environment doesn't help you when a specific critical pump is failing on the floor. That requires micro-level understanding.
Right, you have to zoom in.
The training has to shift from the macro environment down to the actual physical components.
And that transition moves the trainees into the interactive phase of the suite, utilizing an 84-inch multi-touch screen. Think of this as the collaborative dissection table.
It's basically a giant interactive tactical tablet. Multiple people can stand around it, touch it, annotate over it, and manipulate complex 3D models in real time.
Yes, and this is where they do step-by-step procedural walkthroughs. It is a critical step because it forces active learning.
Instead of just passively watching a video.
Right. The team is actively disassembling a one-to-one scale 3D model of that pump with their own hands on the screen. They're discussing the internal mechanics and problem solving together.
And the beauty of this is that if someone makes a sequence error during a teardown on the multi-touch screen, the 3D model simply fails safely on the digital display.
Exactly. It doesn't explode on the actual factory floor.
Which instantly saves millions in potential destroyed equipment. And, if you've ever tried to assemble IKEA furniture using a flat 2D diagram, the absolute frustration of mapping a flat image to a 3D physical space?
Oh, that's the worst.
Now multiply that frustration by 1,000 and add high-pressure steam and toxic chemicals. That's the reality for industrial workers trying to read piping and instrumentation diagrams, or P&IDs.
Yeah, P&IDs are essentially the circulatory system roadmap of a factory. They tell you where the invisible flows of pressure, steam, and chemicals are moving inside the solid steel pipes.
It's basically impossible to visualize.
Trying to map that complex, invisible reality from a flat sheet of paper onto a massive physical machine is incredibly difficult and prone to disastrous errors.
So to solve that specific translation problem, the EON suite uses a 55-inch transparent display. You can literally see floating, annotated 3D schematic images overlaying the physical space or parts behind the transparent glass.
It bridges that cognitive gap completely.
Yeah, between the theoretical diagram and the physical reality you were looking at.
And once the team understands how all these components fit together, the training has to become even more visceral. We have to start encoding the physical memory of the task. That is where we get to the holographic display.
I love this part. This is a glasses-free 45-view 3D display that creates an incredible floating schematic effect for part-level visualization. You don't need any clunky headgear at all.
You just look at it, and the part is floating in midair.
It's like magic.
The technological nuance here is really vital. A 45-view display means that as you physically move your head, bend down, and walk around the display, the 3D image's perspective shifts perfectly.
Just mimicking how light bounces off a real object.
Exactly. But the visual fidelity is only half of the equation. When you combine that 3D object with the 5.1 spatial audio we discussed earlier, you are actively hacking the human brain's memory centers.
I really want to dig into that because earlier you said this actually builds muscle memory without the person performing the physical action. How does hearing a sound while looking at a hologram trick the central nervous system?
It comes down to how the hippocampus encodes survival information and spatial mapping. Our brains are evolutionary machines designed to map threats.
Okay, go on.
When you present a learner with high visual fidelity combined with hyper-accurate spatial sound, for example, the precise deafening hiss of a high-pressure valve releasing right over their left shoulder.
Yeah, the brain gets tricked.
Exactly. The brain does not process that as abstract information. The hippocampus actively encodes that hiss as a spatial marker in a physical reality. You are creating sensory memory.
So they actually remember feeling it.
Yes. When that worker finally walks onto the real factory floor and approaches that real valve, their brain instantly recognizes the environmental cues. That recognition drastically reduces panic, lowers their heart rate, and prevents the hesitation that usually leads to a fatal mistake.
That is absolutely wild. You are artificially generating real-world experience. You are basically installing the veteran operator's hard-earned instincts directly into the new hire's brain, entirely without the danger.
Which perfectly sets the stage for the final step of the cognitive ladder, which is the solo flight, the VR training station.
This is the fully immersive, isolated VR headset experience, and this is strictly for individual assessments, hazardous scenario simulation, and things like LOTO procedures.
We should definitely unpack LOTO because it is one of the most critical and dangerous procedures in any industrial setting. LOTO stands for lockout, tagout.
Right, physically locking a machine.
Yeah, it is the physical act of isolating a massive piece of machinery from its power source before you perform maintenance. It usually involves physically clamping a literal padlock onto a main circuit breaker.
So that no one else in the facility can accidentally turn the machine on while you have your hands deep inside its gears.
Exactly. And if you mess up a LOTO procedure in the real world, you don't just get a warning from your boss.
You lose a limb or worse.
Exactly. The stakes could not be higher. But in the VR training station, the trainee is isolated in a hyper-realistic simulation. They have to walk through the entire LOTO procedure under simulated pressure.
Finding the right breaker, applying the digital padlock.
Yes, and verifying the power is dead. If they fail to lock it out properly, or if they tag the wrong breaker, the simulation triggers the visceral consequence.
The machine turns on.
The alarms blare. They experience the psychological shock of the failure without losing their life or destroying a multi-million-dollar asset.
They get to fail safely, and they can repeat that failure over and over again until the correct procedure becomes absolute second nature. This has to drastically accelerate the onboarding timeline.
Oh, entirely.
Earlier, we talked about the massive financial drain of it taking 2 to 3 times longer to train new hires. With this kind of immersive repetition, you are compressing years of slow, dangerous experience into just weeks of safe simulation.
And because it is a digitized, software-driven ecosystem, that deliberate progression ensures absolute consistency. You deliver the exact same high-quality learning experiences to a new hire in Texas as you do to a new hire in Germany.
That consistency is crucial. So what does this all mean for the organizational bottom line? We've explored the cognitive ladder, the holograms, the neuroscience, but how does a company actually justify the upfront capital expenditure of a massive suite like this?
It all comes down to compliance.
Right, how does it satisfy the federal regulators who are constantly breathing down their necks?
The entire system hinges on one incredibly powerful integration, the Learning Management System, or LMS. The Immersive Learning Center is not just a high-tech sandbox for employees to play in. It is deeply integrated with an AI-powered competency verification system.
So the AI is actively grading your performance in real time.
Yes. As a trainee completes the interactive modules on the touchscreen or executes the LOTO procedure in the VR headset, the AI is tracking everything, every eye movement, every sequence choice, every reaction time.
That's incredible.
And then it automatically generates unalterable compliance records tied directly to those assessments.
Wow. Think about the implications for an audit. If a federal safety inspector walks onto your site and says, "Prove to me that this 22-year-old employee knows how to safely vent this highly toxic chemical tank."
You don't just hand them a crumpled sign-in sheet from a Tuesday morning lecture hall.
Right. You hand them indisputable, automated data. You pull up the AI-verified assessment that proves, mathematically, that the employee executed that exact dangerous procedure flawlessly under simulated pressure 5 different times.
It completely strengthens your audit defenses and eliminates the guesswork of human evaluation. An organization no longer has to cross its fingers and merely hope that a worker was paying attention while reading Chapter 4 of the manual.
I really want to highlight a powerful insight from our sources here. Dan Lajerskar, the chairman of EON AI Ventures, stated that this specific combination of immersive tech and AI verification turns training, and I quote, from a cost center into a strategic advantage.
That phrase perfectly synthesizes what this technology achieves at the highest level.
It really does.
For decades, the industrial sector has viewed training as a necessary evil. A frustrating line item on an annual budget that pulls productive people away from their real jobs on the floor.
But when you deploy an integrated system that captures the knowledge of retiring veterans and installs it safely into new hires,
Training stops being a cost. It becomes a strategic advantage because you are actively shielding the organization from million-dollar regulatory penalties, slashing onboarding time, and above all else, protecting human lives.
you are creating an airtight, verifiable safety culture. It truly is a paradigm shift. We started this deep dive looking at a terrifying 50% retirement crisis, where irreplaceable knowledge is hemorrhaging out the door.
Right.
But by capturing that knowledge in an AI-driven immersive training ecosystem, industries can prevent that massive spike in fatal errors. It's a remarkably elegant solution.
It is an incredibly powerful tool. However, observing this shift raises a fascinating, perhaps unintended consequence. Something we really must consider as the sector moves toward this digital future.
Ooh, I love a good unintended consequence. What are you seeing?
Well, if the entire next generation of industrial workers is trained exclusively on perfect, flawless, AI-driven digital twins of this complex machinery,
Yeah.
what happens to their psychological resilience when they finally step onto the real factory floor and encounter the messy reality of a 20-year-old machine?
Oh, wow. A physical machine that is covered in industrial grime.
Exactly. One that vibrates with an unpredictable rhythm, that has a pressure gauge that always sticks just slightly before snapping to the right number. It simply does not behave like its pristine, beautifully rendered digital simulation.
That is a phenomenal point. The digital twin doesn't have a stripped screw or a rusted lever. The real world is incredibly messy and unpredictable.
So we have to wonder, will relying solely on hyperrealistic, perfect simulation training eventually make workers less adaptable to real-world unpredictability?
Like, when the pristine digital twin they memorized in VR doesn't perfectly match the physical rust of the actual facility, will that cognitive dissonance cause them to freeze?
Right. Are we replacing the dusty paper manual with a digital illusion that is just a little too perfect?
That is definitely something to chew on as these technologies become the new standard. Well, that brings us to the end of today's deep dive into the future of industrial training and the neuroscience of immersive learning.
It's been a great discussion.
Thank you for joining us as we unpack the staggering demographic shift in the technology racing to catch it. Keep questioning the systems and the world around you, and remember, whether you're reading a dusty old manual or interacting with a perfectly rendered glowing hologram, there's always more beneath the surface. We'll catch you next time.